8.5 is about the law of sines. Now, the last stuff we've been talking about, the SOHCAHTOA stuff and everything else there, all had to deal with right triangles. Well, what happens if you don't have a right triangle? You can still use trig in those issues here too. So this is what we call the law of sines. And then the law of sines relates the sine of each angle to the length of the opposite side. So if you look here, sine of A divided by A equals the sine of B divided by side B equals the sine of C divided by C. So if we want to use that in triangle ABC, measuring angle A is 48, measuring angle B is 93, and AC is 15. What is the length of BC? Again, draw a triangle. Doesn't have to be a right triangle. Who knows what it is? A, B, C. They tell me this is 48 degrees. Tell me B is 93 degrees. And they tell me AC is 15, which is right here. So I know the length of BC. Let's call it X right there. So using the law of sines, how are we going to do that? Again, what's across? X is across from 48. So the sine of 48 over X equals the sine of 93 over 15. We have two proportions, pretty simple, cross multiply and divide. You get X times the sine of 93 equals 15 times the sine of 48. Punch in your calculator, we'll get that. Don't do it right here, do it later. Divide both sides by the sine of 93, because you don't want to round too early. That cancels, I get X equals, punch all that in your calculator, 11.16. Problem 2 talks about a triangle RST, and you can read the rest of it. So again, draw a picture. Doesn't matter which triangle looks like. RST. RT is 11. ST is 18. And they tell me R is 120 degrees. They want to know what measurement of angle S is. We don't know what that is. So let's go from there. Again, angle R, which is 120, so the sine of 120 divided by 18, because that's opposite the 120, equals the sine of X divided by 11. Cross multiply, you end up with 18 times the sine of X equals 11 times the sine of 120. Divide by 18, you end up with the sine of X. Again, punch on your calculator, 11 sine of 120 divided by 18. Okay? Gives me approximately 0.5292. And again, do not round here. Don't round till the end. Want to now solve for X, so I'm going to take the inverse sine of both sides. That's going to cancel that, take the inverse sine of that. That's why you do not want to round there. X equals the inverse sine of that, which is going to be 31.95. And then round to wherever you want it to. We'll leave it there for now. Problem 3, we kind of already drew it for you. A ship can only sail 42 miles. Can the ship sail safely to either lighthouse? So we know it's 70 degrees here, it's 52 degrees here. The ship is over here. Can I sail to either one? So let's kind of solve for X and for Y. Okay? Let's take a look. Since we have 70 degrees and 52 degrees, we know it's a triangle, so 180 minus 70 minus 52 leaves me with 58 degrees right there. And that's going to be huge because it's going to help me be able to solve for those things. So let's solve for Port City first. Okay, so the sine of 58 divided by 40 equals the sine of 52 divided by X. Let's solve for X. Let's see how far that is. So X, the sine of 58, equals 40, the sine of 52. Divide by the sine of 58. That's gone. X equals, again, punch it all in your calculator, about 37.17 miles. Let's do Covetown. Okay, again, same thing, sine of 58 divided by 40 equals, and we're doing Covetown over here, which is Y, the sine of 70 over y. Cross multiply, you get y sine of 58 equals 40 sine of 70. Again, divide by sine of 58. Y is going to be plunked it all in your calculator. You end up with 44.32. So to answer your question, can you sail safely to either lighthouse? The answer would be yes, you can sail safely to Port City.